ओके गुड मॉर्निंग। आई होप यू डूइंग वेल। आज का जो टॉपिक है वो है इंडस्ट्रियल टेम्परेचर मेजरमेंट। इंडस्ट्री ऑयल एंड गैस सेक्टर में टेम्परेचर को मेज़र करना कितना इम्पॉर्टेंट है और क्यों मेज़र करना चाहिए। वाई इज टेम्परेचर इज इम्पॉर्टेंट or temperature is important process variable, and why it is necessary to measure and control it. As you know, temperature is one of the process variable, which is we can say is control variable. Very important. Temperature is very important. Need to measure accurately and controlled. A lot of benefit, plant safeties, as well as the chemical, the product you are getting the final product, the chemical reaction will be taking place due to the temperature, because crude in oil and gas industry, the crude they are going to heat it in the furnace, in the heater, and they given the desired temperature. After getting and heating the crude or desired temperature, it will be changed the reaction, and then after the sending to the cool down. So all this process in the oil refinery. So temperature as one of the important process variable which is need to be measured and controlled. Then second thing is the equipment. We are using the so many equipment, the mechanically and the process point of view. There is a lot of exchanger, heat exchangers. There is a lot of the pumps, the compressor, the pipes. All these things is there is the design pressure. The maximum design pressure should not be design temperature, design pressure. So your temperature measurement will be as the desired. You should not go beyond these values. Should not be reach the design the maximum temperature or pressure. Otherwise, something will happen. It is not safe for the plant. So to control the temperature to get the final product. So by this way, you are in efficiency, plant efficiency, the product qualities, and then equipment efficiency, performance, everything you can maintain. So there is a lot of method to measure the temperature. The temperature sensors commonly used RTD. RTD stands for the resistance temperature detector. And another temperature sensor which is very important is the thermocouples. I already explained in the previous class how to what is the RTD, or what is the and how it is working, which principle, what is the output, all these things important. So RTD stands for resistance temperature detector. Okay, this resistance temperature detector measuring the low temperature, the minus 200 degree to 650 degree centigrade, which is class A, and the class B is a minus 200 degree centigrade to 850 degree centigrade. So the temperature RTD is very common. And then thermocouple. Thermocouple also they are using where there is a high temperature in the process. So the sensor is very common. If you will see in the plant, so as an instrument technician, you must know and must familiar what is the RTD, how it is working, what principle, what will be the output, how it is installing the plant. This is very important for your skill. So need to improve your technical skill as well as technical knowledge. And then thermocouple, how it is working. Two dissimilar metal wire are joined at one end. It is called a hot junction. Another junction, it is called a reference junction and cold junction. All theory part I already covered. So just focus on this very important thing which I am delivered now. So the thermocouple also very important. Okay, that simplex and duplex, all types of the thermocouple coming. If you see the RTD, that is also simplex and duplex, and then that is wiring, the configuration, two wires somewhere very rarely used because of having the error in the reading, so that sensor is avoided. Three wire is commonly used, PT100 platinum, which is very accurate and very good reading for the 3 wire RTD. So all this sensor is commonly used in the plant. So instrument technician, you are going to attend the interview, you should be focused for the basic things which is commonly asked in interview. So the thermocouple output is millivolt. Okay, then if you see the PNID, if you refer the PNID, they are given the open loop, the design, and then closed loop. So what is happening if you read the PNID and interpret in correct way, so how it will be? So there will be the process line like this. Okay, there is a process line. Okay, in this process line there is a TW. TW means thermowell. Okay, thermowell, and then there is a TE, temperature element, as a sensor, for example RTD. Okay, then this RTD will give the output, as you know, this is the resistance ohms. Then it will be going to the temperature transmitter. Temperature transmitter, this receiving the ohms, the resistance, and converting into the electrical signal, which is 4 to 20 milliamps. As you know, so this temperature transmitter output, the standard output is 4 to 20 milliamps DC. So temperature transmitter doing two things. One is accepting, receiving the ohms value, which is the resistance, and converting into 4 to 20 milliamps. So like this, it is working, and then it will go to the DCS. That if there is an open loop, the TI block is there. So TI block means temperature indicator. So this is the open loop. There is a thermowell in the pipeline, and there is thermowell. Inside the thermowell, you have to put the sensor RTD to protect the sensor to not to damage. Okay, maybe the process pressure, like this, some harsh condition of this thing. So thermowell, it is the basic design. If you will see the refer the PNID, you will get the clear picture. And how to read, I just explained the same way. You try to understand for the explanation. Okay, then it will be the closed loop. What will happen closed loop? There is a pipeline. Okay, there is a TW thermowell. Okay, inside the thermowell there is a sensor, which is RTD here for our case, and then there is a like this dotted line they are showing. That means the output, this output, right? Then it will go again to TIT, then again converting 4 to 20 milliamps, which is electrical signal. Okay, then it will go to control block from DCS like this. Okay, this is TIC. Okay, then TIC here will be the PV, means temperature transmitter, accepting the sensor what is the output. Okay, that ohms, and then sending to the controller as a PV. Then controller having the SP, which is the process DCS operator is given the desired set value to control the temperature. Okay, based on this PV and SP, that controller again calculating and then give the MV, which is manipulated. It will be also 4 to 20 milliamp signal like this, and here it is the control valve on the same pipeline. So this control valve will be accepting, receiving the signal from the controller and operating as per the set value. So by this way you can also explain. So here will be the TCV, temperature control valve. So the entire loop, it is working in this manner. So here is temperature thermowell. There is some tag number, for example 001. Okay, that TE also 001, and TIT 001, and TIC 001, and TCV 001. So this closed loop means there is a feedback. Once you put the SP, your desired value according to the set value, the controller is calculating and giving the MV, which is 4 to 20 milliamps output, and sending to the control valve to control the temperature. So I hope as per my explanation you understand fully. If there is a doubt, if there is some confusion, need to ask something, some more question, you can comment directly to me, and you can ask. So thank you for your time and attention.